Let's look at page 12 and 13. We're building on some of these concepts, and we've done factorial notation, we've done permutations. Now this is called, by the way, I hope you did well on your checkup. That was your goal yesterday. A combination is just a little bit different. Permutations, the order of the objects is important, whereas in a combination, the order does not matter, okay? And that's down here in this box at the bottom of the page. And there is a formula here. I wrote it up here on the board. So a combination means it doesn't matter what order you put them in, if they're together, they're together, okay? Let me give you an illustration, and then we'll talk about the formula. Take the word hat. What are the different ways you can arrange the letters in the word hat? Well, I can put H, if you're only taking 2 letters at a time, I should say. I could put H with A. I could put H with T. I could put A with T. Now you might be tempted to say, well, I could put T with H, but look, that's already covered here. HT is the same thing as TH. So I could put T and A together. I already have that. I could put A with the H. Well, we already have that because the order doesn't matter. So there's really only 3 ways to take these letters and arrange them. And the formula says I could figure that out by taking the total number of letters, in this case 3, so 3 times 2 times 1, and divide by, in this case, 2 times 1. All right? So 3 times 2 times 1 divided by 2 times 1 times 1 would be 3. And sure enough, that's what I get. Let's take a different example. Let's say we have 9 students, but there's only 5 chairs. We're going to play a game, let's say. And there's only 5 students who can participate in this game. How many possible ways, and it doesn't matter, who's going to sit in what chair, it doesn't matter, it's just what are the combinations that we can come up with of these 9 students. So 9 would represent the N, all right? 5 represents the R. So to solve that, we're going to do 9 factorial over 5 factorial times, and then we subtract 9 minus 5, N minus R, 4 factorial. Okay, so let's write out 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. All right. Putting dots between all of these, so this, they all cancel. There we go. All right. 3 times 2 is the same as 6. And then I can cancel the 4 against the 8 and have 2. So the answer to this would be taking 9 times 2, use your calculator, and take that times 7. All right? So even if all of the whys and wherefores don't make sense to you, the formula is fairly easy to use, especially with the calculator. And they show 2 more examples up here at the top of page 13 using the numbers 7 and 2 and 11 and 4. And so 1 through 5 should be fairly easy. 6 through 11 really are the same. It's just that they're like a word problem, and you just have to figure out there's 2 numbers, which one is the N, which one is the R, and then solve using this new factorial method. All right, cancel out what you can and see what's left. All right, we'll come back for page 14, 15 in a little bit.